Hello, dear viewers. So, welcome to session 3, part C. We solved question number 21 in session 3, part B. Now we want to look at question number 22. Okay. The figure below shows an electric circuit. Define the following: potential difference and resistance. How do you define potential difference? It's always about the energy being transferred by each unit of a charge. So here we can say potential difference is the energy per unit charge, of course, as it moves from one point to another. Energy per unit charge as it moves from one point to another. So if you want to get the potential difference, we always use the energy transferred. You can also give this one as your answer: energy transferred or the work done. Let me just write W D to mean work done over the charge. Okay. Resistance. What is resistance? It's about what? The ratio of, so we have the potential difference and the current. So the ratio of the potential difference and the current in a circuit. So this one, R, resistance is always given by V over I. Yeah, we always have V over I. Okay, the next one. Here we are being asked to now calculate the internal resistance R. Calculate the internal resistance R. So here what do we have? This is the electromotive force. What we have here is what we call the terminal potential difference. Yeah, what will be supplied. And then here we have the internal resistance. So how are they related? If we add, E should be equal to the terminal potential difference, that is 10, plus the voltage being lost due to internal resistance. How do you get the voltage? V is equals to I R. So R is not known, but we know the current is 2 amperes. So we have 2 R. So it's like we have now 12 is equals to 10 plus 2 R. So 10 will cross to that side. So we'll have 2R is equals to 2. What is R? Therefore, R is equals to 1 ohms. You divide both sides. Divide both sides by 2, you get 1 ohm. That is the internal resistance. And then part C, we are being asked to find the value of resistance R2. Yeah, R2 is here. We want to get the value of R2. So how do we get the value of R2? There are a number of ways, but I want to give you the easiest way of getting R2. Now R2 and R1, they are in which kind of a connection? In a parallel connection. In a parallel connection, we always have what? We always have the same, they always have the same voltage, the same potential difference. So are we able to get the voltage through the 3 ohm resistor? Yes, because we have the current through it. But here, what do we know? We don't know the current, but we can get the current. If we get the current and we can get the voltage from this side, then we can get the value of R2. Which one do we start with? Let's start by getting the current. Okay, I2. I1 is 1.33 and I2 is not known. But look at this one. The current in this circuit, these two, I1 and I2 will come, they'll get here and then combine to form the current, which is 2 amperes here. So in short, if you add I1 plus I2, you're supposed to get 2 amperes. But we have I1, so I2 will be equal to 2 minus I1, which is 1.33. So what do we get? We end up with what? 0.67. So I2 is equals to 0.67 amperes. Okay, we know the voltage here, 0.67 amperes. Now we need to know the potential difference, the voltage here, because we know the current. Yeah, we know the current, and now we need to know the voltage. So how do we get to know the voltage? I've said the voltage through the R1, that is the 3 ohm resistor, is the same as the voltage through R2. And V is always equal to I times R. I here is 1.33 and R is 3. So what is the voltage? So 3 multiplied by 1.33, what do you get? You end up with 3.99. So V is equals to 3.99. If you round it, you'll get 4. But let's use it the way it is. So the voltage here, V is equals to 3.99 also. Now we want to get R. How do we get R? R is equals to V over I. R2 now will be equal to V, which is 3.99. We divide by the current through it, which is 0.67. So 3.99 divided by 0.67. So you end up with 5.96 ohms. These are approximately 6 ohms. So R2 is equals to 5.96 ohms. You can use other ways to get the same thing, but this is the shortest route to get it. Okay, we have come to the end of session 3. In session 4, we look at some more questions still on electricity. Yeah, still on electricity from the same booklet that I have been getting the questions from. Yeah, thank you and see you in the next session.